To appreciate standard form, we need to go back to the concepts which we learned in indices. So let's recall the rules of indices. An index, we can also refer to an index as a power. When a number is raised to a certain power, n, it is being multiplied by itself n number of times. For example, if we say 3 to the power of 3, for example, in this number which we've written here, what we are saying is 3 is being multiplied by itself how many times? 3 times. So 3 is being multiplied by itself 3 times. So it means 3 times 3, which is equals to 9. Then 9 times 3 gives us 27. All right. And we move on to the next one. Let's try another one. 5 to the power 4. 5 to the power 4, what it means is 5 is being multiplied by itself how many times? 4 times. 4 times. So 5 to the power 4 is 5 times 5. This one gives us 25. 25 times 5 gives us 125. 125 times 5 gives us 625. So these are the rows of indices. We can also try to perform this on a calculator to cross-check if our working has been correct. I'll use my calculator here. So what you need to do when using a calculator, you press this button 3, then you press this button x to the power y. The calculators obviously may be different. Others will just have that small, maybe Chinese head sign, and then you press 3 and then you get your answer. So we already got our answer. Our answer is equals to 27 here. So we just write our 27. Now you can try these ones. 2 to the power 3, which means 2 times 2 times 2, or 3 to the power 2, which means 3 times 3, or 2 to the power 5, meaning that 2 is going to be multiplied by itself 5 times. So I'm just going to do this one. You can pause the video here and solve these ones and proof so that you can see if you've been working, following along nicely with us. So it's 2 times 2 times 2 times 2 times 2. This gives us 2 times 2 here, this 4 times 2, 8 times 2, 16 times 2, 32. All right. So you can do that on your calculator, proofread, and check if that's the correct answer. Next, we want to look at powers of 10. So powers of 10 are quite easy. For example, we have this number here, 10 to the power 2. So 10 to the power 2 is simply 10 multiplied by 10 and giving us 100. All right. So how many zeros did we get here? You can see here that we got 2 zeros. 1, 2. So let's look at this sequence of numbers. Here we have 1000 here, and here we have 100, here we have 10, here we have 1, 0.1, 0.01, 0.001. You can see here that as we move from the left going to the right like this, you can see that we are dividing by 10. 1000 divided by 10 is 100, 100 divided by 10, 10. 10 divided by 10, 1. 1 divided by 10, 0.1. 0.1 divided by 10, 0.01. And 0.1 divided by 10, 0.001. So we now want to convert these numbers to other forms, to standard form, and see how far we can get with that. From this, you can see here that we have 1000, and our 1000 can also be written as 10 to the power 3. Why? Because let's say we are working with this number. To convert this, you can see here that since 10 to the power 2 is already 100 and it has 2 zeros, what it also implies is 10 to the power 3 is equals to 10 times 10 times 10, giving you 1000, since 100 times 10 is equals to 1000. So here 1000 is also equals to 10 to the power 3. 100, we've already worked that one, is 10 to the power 2. And 10 now is simply 10 to the power 1. All right. But now as we get to the units, you notice that our powers continually are decreasing. Here it was 3, here it's 2, here it is 1, here it is 0. What do you suppose this next power will be? Obviously, if we are continuing to move just divided by 10, then it must also mean that the next power will be minus 1, minus 2, minus 3, and so forth and so forth. So you can observe here that 10 to the power 0 is equals to 1, 10 to the power minus 1 is equals to 0.1, and 10 to the power minus 3 is equals to 0.001. Taking note of the fact that this number here, 10 to the power minus 3, is the same as saying 1 over 10 to the power 3, which is also the same as saying 1 over 1000. So you can see that in order to write powers easily, we just write 1, and then the number of zeros is equal to the power or the index. For example, if our power is positive, then it means that our number is not a decimal, it has got positive, it's a positive number, and just have 2 zeros. If we have our power being 1, our number is just 1 and 1 0. And if our power is 0, that means that we just write that 1, no zeros to add. There are no zeros. But if the power is negative, then it means that the number of zeros are going to be on the decimal side. For example, 10 to the power minus 1 is equals to 0.1. We're going to just have one decimal place going to the right. All right. We're going to just have one decimal place. Delete part here to the right. So the power of 10 here is the one which is being called the index. And standard form now is a way of writing very large and very small numbers using powers of 10. In this form, which we call the standard form, a number is given a value between 1 and 10 and then multiplied by a power of 10. To summarize it, we are saying that standard form is in this notation: a times 10 to the power n, where a is any number which is equal to or greater than 1 but less than 10. What we are saying is all numbers in standard form should start from exactly 1, be it 1.2, 1.3, up to 9.999999999, because 10 is greater than this value. And n is any whole number, whether it is positive or negative, which we call integers. So n is an integer, and a is a number between 1 and 10, with 1 included but 10 being excluded. Let's try some problems. So follow through these examples to see how we can write numbers in standard form. Here we have a partially worked example. 52 is a common number. We can rewrite it as 5.2 times 10. Already it is in standard form by this, because this first number a is satisfying the condition that the number should be between 1 and 10, so this one is okay. And now the power of 10, since we have just multiplied by 10, the answer would be 5.2 times 10 to the power 1. That's simple enough, right? Let's try another one. 73, using the same method, it must also imply that 73 can be written as 7.3 times 10. And we can, again, since this number is between 1 and 10, it satisfies the notation, and hence it will be 7.3 times 10 to the power 1. Let's try another one. 625. Now this one is a bit different. You can see here that this number is in the hundreds form. So to convert it to decimal form, we can divide by 100 to get 6.25. So it will be 6.25 times 10 to the power 2, because we've divided by 100. So the number, it means that the number is being multiplied by 100, or 10 to the power 2. And our answer will be, or we can just write this one as 6.25 times 10 to the power times 100, giving us 6.25 times 10 to the power 2. Let me give you a simple tip to follow here. For example, let's say you have a problem like this one, 625. Let me give another number, 1092. All right. In this example, we have 1, 2, 3, 4 digits. And all whole numbers can be written in decimal form like this, as the whole number 0.0. So in order to convert a number to standard form easily, you can also use this method. Move the decimal point and number of places either to the right or to the left until you get a number which is from 1 up to less than 10, and the other one becomes a decimal, and then you multiply by the number of places which you move the decimal point. For example, our decimal point is here. In order to satisfy our standard form notation where a is less than 10 but greater than or equal to 1, we can move our decimal point until here, so that this number becomes 1.092, because 10.92 will not work, 109.2 will not work, because we will not have satisfied the conditions of standard form. So we need to bring it here. So our decimal point, we can move it 1, 2, 3 places, and then the number becomes 1.092 times 10 to the power. The number of zeros is equal to the number of times the decimal point is moved to the left, which is equals to 3. So you can rewind this or pause and try out this method in these other problems and see if it satisfies this solving method, or if it satisfies the standard form and you still get the same answer. So those numbers in the white boxes are the numbers in standard form. Here you can see that we can also first convert a number and see the number which we multiply it by. For example, 389 can be rewritten as 3.89 times 100, which gives you 3.89 times 10 to the power 2y. Because we said to write a number in standard form, we just write the number of zeros is equal to the power or the index. All right. Another example, 3147. You can see here again that this number can be rewritten as 3.147 times 1,000, which we can rewrite in standard form now as 3.147 times 10 to the power 1, 2, 3 zeros. All right. So when writing a number in this way, you must always follow these two important rules. The first part must be a number between 1 and 10. 1 is included, 10 is not. The second part, which is the index, must be an integer or a whole number. That is, it can be negative, it can be positive, it can be 0, and it is a power of 10. These are the two important rules which you must follow when converting ordinary numbers into standard form. Generally, you can note that we do not normally write the power of 1 as, like, let's say for example a number like let's say this number 20, right? 20 in standard form would be, the decimal point is here, so we move the decimal point one place to the left, so our number is 2 times 10 to the power 1. You can leave it in this form, and it is also allowed to just leave it in this form, 2 times 10. It's also allowable. But for you to have more clarity and for it to be easier for you to remember so that you can solve any kind of problem, it is always better to include the index. Let us now move on to some worked examples in standard form. We say that standard form is important for two main reasons. It allows us to write really small or really big numbers concisely in a more readable form, which we call scientific form. And it also allows us to compare these small or these big numbers. All right. So we said again that the standard form is written in this notation: a times 10 to the power n, where a is any number from 1 up to 9.9999 and n is any whole number, be it negative, positive, or 0. Let's look at these two numbers. Which one is bigger between this number and this one? Note that it is very difficult to compare these numbers because they are basically the same. But if you rewrite them in this standard form, you can see that since this number and this number are the same and the base is the same, only the powers are different. And since this power is greater than this one, you can tell that this number automatically is greater than that one. 2.34 times 10 to the power 14 is obviously greater than 2.34 times 10 to the power 13. Can you perform this calculation on a calculator? 4.86 times 10 to the power 21 divided by 2.88 times 10 to the power 9. You can pause the video here. Whilst you do your calculations, I would highly advise you keep your calculator closed only for this kind of problems, and please share your answer in the comments below. Let's try some problems. So first we're going to try converting from standard form to ordinary form. It is very easy to do this. We just look at how many times we are multiplying or dividing by 10 and then move that certain number of places either to the left or to the right. Here we have a problem, 3 times 10 to the power 4. Since our power of 10 is positive, it means we are going to move to the right. So it will be 3 times 1, and how many zeros? 4. 1, 2, 3, 4, and this will give us 30,000. Let's check if our answer is correct. Yes, our answer is correct. It's 30,000. Let's try another one. 6 times 10 to the power 3. Now you can see here that our power is negative, so we're going to move to the left. So it will be 6 times 1 over how many zeros? 1, 2, 3. So it's also the same as 6 divided by 1, 2, 3. This is basically the same thing. Alright, 6 divided by 1000. So since our 6 is here, it's 6.0. We need to move our decimal place how many times to the left? 1, 2, 3, since we are dividing. So it will be 1, 2, 3. Our new decimal place will be here. So if our new decimal place is here, it means we're going to replace this with placeholders. Alright, so it will be 0.006. Let's check if our answer is correct. 0.006. Yes, our answer is correct. Let's try another one. 1.24 times 10 to the power 5. Our power of 10 is positive, so we are moving to the right. 1.24 times 1, 2, 3, 4, 5. This index shows us the number of zeros which we should write. So we're going to move our decimal place 5 places to the right. 1.24. So it will be 1, 2, 3, 4, 5. Here we're going to put zeros now, and the new decimal point will be here. So our number will be 124,000. Let's check if it is correct. Yes, it's 124,000. We're good to go. Let's look at the last one here. 1.01 times 10 to the power minus 1. Here again you can notice that the power is negative, and we're going to move to the left. So we're going to be dividing. So since the power is 1 but it is negative, we're going to move 1 place to the left. So 1.01 will be like this: 1.01 divided by 10. This is the same as 1.01 times 1 over 10 to the power 1. So you just find which method is easiest for you. Since we're going to move 1 place to the left, so it will be 1 place to the left, and it will be a new answer like this: 0.101. Let's check if our answer is correct. Yes, 0.101. We are on track. All right, So the hint is to remember what we do when we have a negative index. You can see here that when we have a positive index, we move the number of places to the right. If the index is positive or the power of 10 is positive, we move going to the right. But if the power of 10 is negative, we move the number of places to the left. Right. Now we want to look at some problems converting from standard form to ordinary form. Here we have 3.012 times 10 to the power 7. I'm just going to do one problem so that you can also have time for practice. I'm only going to do one. You do the other ones and cross-check with your calculator. You can also share in the comments so that we can know you're following. 3.012 times 10 to the power 7. 3.012 times 10 to the power 7. We are going to move 7 places to the right or multiply by 1 with 7 zeros, whichever is easiest for you. 3.012, moving 7 places to the right. 1, 2, 3, 4, 5, 6, 7. Our new decimal point will be here, so we're going to replace this with zeros or placeholders. 1, 2, 3 thousand, 1, 2, 3 million. So it will be 30,120,000. That's the number which you got. Let's check if the answer is correct. Yes, 30,120,000. You can do these other ones. You can pause the video and do these other ones. Maybe I'm going to give you maybe 5 seconds or 10 seconds for each problem. 7.5 times 10 to the power 1. This one is easy again. Whilst you work out, I'll be working out here. 7.5 times 10. We're going to move only one place to the right, which will give us 75. So that's very easy, right? So let's check if our answer is correct. Yes, it's 75. Let's look at the other one. 8.31 times 10 to the power 0. So it will be, we're not moving any places because the index is 0. So this number just remains 8.31. Let's check. Yes, our answer is 8.31. And the last one, 2.4 multiplied by 10 to the power 6. It's very simple. We're going to move 6 places to the left because the power is negative. So it will be 2.4 moving 1, 2, 3, 4, 5, 6. All these ones will be replaced with placeholders. Our new decimal point will be here. So our new number will be 0.0000024. Let's check. And our number is, yes, 0.0000024. Now, converting to standard form is also something which we need to look at. How many times do we need to move the decimal point until we're in the range of A is equal to or greater than 1 but less than 10? Let's look at this number, 20,000. So our decimal point is here, 20,000. So our decimal point is here. So what we need to do here is we're going to move our number until we have a 2 here. So let's see how many times we move. 1, 2, 3, 4. So it means our answer should be 2 times 10 to the power 1, 2, 3, 4. 2 times 10 to the power 4. Let's check. Yes, it's 2 times 10 to the power 4. Here we have 931 million. We need to put it into standard form. How many this number can be? We need to make it maybe 9.31. So we need to move our decimal point from the end here. 1, 2, 3, 4, 5, 6, 7, 8. So it will be 9.31 times 10 to the power 8. Let's check if our answer is correct. Yes, it is correct. The next number is 0.0043. To convert it to standard form, 0.0043 is equals to, we need to make it 4.3. 1, 2, 3. So it will be 4.3 multiplied by 10 to the power minus 3. Have you noted the difference? If we move to the left, if we move our decimal point to the left, the power is positive. But now that we are moving the decimal point to the right, the power is negative. Okay? So here it will be 4.3 times 10 to the power minus 3. Let's look at the last one. 0.00000, that long number. So here we're just going to work on it here. How many decimal points? I think we need to bring it here. So it will move the decimal point 1, 2, 3, 4, 5, 6. So it will be 1.001 times 10 to the power minus 6. Okay, let's check. And yes, it's correct. That is our answer there. At this point, you can pause and try out a few problems to express to standard form, to express as normal form. All right. Now, let's just test our knowledge with this simple exercise. Let's give you 10 seconds to solve this part. What was the answer here? Let's go together. Here, since we're going to many places, 1, 2, 3, 4, 5, 6, 7, 8. So our answer should be this one. 2 times 10 to the power 8. And yes, it's correct. Let's move it to the next one. This one, we need to move 1, 2, 3, 4. 3.2 times 10 to the power 4. I think this one, yes, it's correct. 9 is just the same as saying 9 times 10 to the power 0, because nothing is going to happen. We're not going to move any number of places. So 9 to the power 0 is here. Yes, it's correct. We're going to move how many places to the right? 1, 2, 3, 4. So it will be 1 times 10 to the power minus 4, which is this one. Yes. Then 0.012. We're going to move how many places? 1, 2. 1.2 times 10 to the power minus 2. This one. Multiplying numbers in standard form is the next stage. It is important to learn how to multiply and divide numbers in standard form before you're able to add and subtract. No matter how simple you think it is, you understand why in a very short time. Let's look at multiplication. 2 times 10 to the power 3 times 4 times 10 to the power 4. So in multiplying in standard form, we can use some simple mathematical rules which include that if you are doing multiplication like this, then it is very easy. You can even rearrange all these numbers to your convenience and still you'd get the same answer. For example, I'm going to rearrange it to 2 times 4 times 10 to the power 3 times 10 to the power 4. Once I do this, it becomes very easy for me to solve and work this one out because it's in a simple form. Alright, so now once I do this, it will be 2 times 4, that gives me 8. And then when we are multiplying numbers with the same base according to the rules of indices, we maintain the base. This number here, if it is the same, we call it a base. And then we simply add the powers 3 plus 4. And this would give us 8 times 10 to the power 7. Okay, so it will be the same as 8 to the power 1 here times 10. So 8 to the power 1, obviously, of course, just leave it like this. 8 times 10 to the power 7 here like this. Okay, another one, 7 10 to the power 5 times 6 times 10 to the power 6. So we can rearrange it to this form. 7 times 6 times 10 to the power 5 times 10 to the power 6. Again, we can include a step where this number 76 gives us 42, and then 10 to the power 5, it will be 10 to the power 5 times 10 to the power 6. This gives us 10 to the power 5 plus 6, giving us we said this times 10 to the power 5 plus 6, giving us 42 times 10 to the power 5 plus 6, 11. So our number here would be 11. All right. And then this number again is still not yet in standard form. Why? Because 42 is greater than 10. our numbers should be between 1 and less than 10. So 42 can be rewritten as 4.2 times 10 to the power 1, then times 10 to the power 11. Again, we are simply going to add the powers, 4.2 times 10 to the power 1 plus 11, giving us 4.2 times 10 to the power 12 here. Let's look at some other problems. Here we have 9 times 10 to the power minus 2 times 9 times 10 to the power minus 3. The easiest way, like we said, is rearrange. So this one will be 9 times 9 times 10 to the power minus 2 times 10 to the power minus 3. Okay, and this would be 81 times 10 to the power minus 2 plus minus 3. And this would be 81 times 10 to the power minus 5. Okay, let's check here. 81 times 10 to the power minus 5. Again, this 81 times 10 to the power 5 can be written as 8.1 times 10 to the power 1 times 10 to the power minus 5. Now you see why writing this one always is important. Obviously, of course, we can write just times 10, but if you write it and you are doing operations like this, it will help you. This will be 8.1 times 10 to the power 1 minus 5, or plus minus, which will give us minus. This will be 8.1 times 10 to the power minus 4. So in this step here, this is the same step as this one, and then we added another step, and then the final answer will be 8.1 times 10 to the power minus 4. All right, just take a second to absorb that. Let's move on. Dividing numbers again in standard form is also easy. You just need to do the reverse of what you were doing in multiplication. For example, here it's 4 times 10 to the power 5 divided by 8 times 10 to the power minus 2. This can be rewritten as 4 divided by 8 times 10 to the power 5 divided by 10 to the power minus 2. When we have done this, it becomes very easy. When we are dividing now, it is different. Whereas in multiplication, we're adding the powers according to the rules of indices. When we are dividing with indices or numbers in index form, we subtract the powers. For example, here it will be 4 over 8, the same as 0.5 times 10 to the power 5 minus 2. This will be equals to 0.5 times 10 to the power 5 minus 2 is the same as 5 plus 2, which is equals to 7. So this still is not yet in standard form. Why? Because the first number is not in standard form. It is less than 1. So we can rewrite this number as 5 times 10 to the power minus 1, because it's a fraction. It is 5 over 10, which is same as 5 times 1 over 10, which is 5 divided by 10, which is 5 times 10 to the power minus 1. Here, times 10 to the power 7. So 5 times 10 to the power minus 1 plus 7, which gives us 5 times 10 to the power 6. Let's check if our answer was on point. 0.5 times 10 to the power 7 here. So we added this step and we got to this one. And then we converted this 0.5 to 5 times 10 to the power minus 1. Then the final answer was 5 times 10 to the power 6. Let's try another one. 3 times 10 to the power minus 10 divided by 8 times 10 to the power minus 6. Here it is the same as 3 over 8 times 10 to the power minus 10 minus 6. Because we're saying that 10 to the power minus 10 divided by 10 to the power minus 6 is the same as 10 to the power minus 10 minus 6, which gives us 3 over 8 times 10 to the power minus 10 plus equals to minus 4. But this number is less than 1. 3 over 8 can be written as a decimal as 8 into 3, that's 0.8 into 30, that's 8 into 3, 0. 8 into 33, remainder 6. 8 into 60, That's 7 remainder 4 and 8 into 40 5. So that's 0.375 times 10 to the power minus 4. This number is still less than 1, so we need to convert it to standard form. 3.75 times 10 to the power minus 1, because we just moved one decimal place to the right, so the power is negative 1 times 10 to the power minus 4. This would give us 3.75 times 10 to the power minus 1 minus 4, which would be 3.75 times 10 to the power minus 5. Let's cross check. 0.375 times 10 to the power minus 4, which is this step here, and then finally 3.75 times 10 to the power minus 5. Now let's move on to the final part, which is addition and subtraction. If we look at this number 1000 plus 2000, this is a very simple addition. With the zero, we have 3 zeros, so it will be 0 0 0, and then 1 plus 2 gives us 3, right? So our answer would be 3000. In standard form, it would be 1 times 10 to the power, how many zeros do we have? 3, plus 2 times 10 to the power, how many zeros do we have? We have 3 again. So if the bases are the same, then it is simple as just adding these two numbers, okay? And it would be an answer like 1 plus 2 times 10 to the power 3, which would be 3 times 10 to the power 3, okay? So it will be times 10 to the power 3 times 2 times 10 to the power 3, which is equals to 3 times 10 to the power 3. Let's try another one. This one is a bit different. 4 times 10 to the power 3 plus 2 times 10 to the power 4. We can see here that the powers of 10 are different. To the power 3 is to the power 4. What you can do here is you can either convert all of these numbers to power 4, both of these ones, or you can convert them all to the power of 3, so that you can be able to only add these ones, okay? The easiest thing would be to add them to the power which has got the highest, to the number with the highest power, because it would be, since we're adding them, then the number would obviously be greater, and we have this power of the highest power of 4. For example, here it would be 0.4 times 10 to the power 1 times 10 to the power 3 plus 2 times 10 to the power 4. Where we would go from here is, it would be 0.4 times 10 to the power 4, since here it's 1 plus 3, which then plus 2 times 10 to the power 4. Now we've rearranged this one to this step, and now to this step where we have 2 powers of 4 and it's easier to add. We're only going to add these ones, which will give us 2.4 times 10 to the power 4, okay? Obviously, of course, you can choose to convert both of these numbers to numbers to the power of 3. For example, what we'll do is 4 times 10 to the power 3 plus 2 times 10 to the power 1 times 10 to the power 3, okay? So here it will be 4 times 10 to the power 3 plus 2 times 10 gives us 20 times 10 to the power 3. Then it will be 20 plus 4, which is 24 times 10 to the power 3. But now this 24 is not in standard form because it is greater than 10. What we need to do is we need to reconvert this number to a number between 1 and 10, 1 included and 10 excluded, which will mean that we have to again come back to 2.4 times 10 to the power 1 times 10 to the power 3, which was a step which we already did in another calculation there, and it will be 2.4 times 10 to the power 4. So in my opinion, I think converting, if we have numbers, you are adding numbers with different powers of 10, then it will be more convenient to convert both the numbers in brackets to the power of the number with the higher power of 10. For example, here we're 10 to the power 3, here we're 10 to the power 4. So it was easier or more convenient to convert to the power of 4, and we took less steps as compared to this. Okay, so let's cross our answer, and yes, this is the easiest method. There is also another method of adding numbers in standard form. You can convert them to the ordinary form first and then add the numbers. When you get the answer, then reconvert back to standard form. For example, here 1 times 10 to the power 3, you can convert it to 1,000. 2 times 10 to the power 3, convert it to 2,000. Then your answer, you calculate these two, you get your 3,000, then you come back to the answer. Okay, so you can use this, but if the numbers are very large, then it may become tedious, and if you are not using a calculator for paper 1, then the problems may become very complicated and may be discouraging, or you may make a lot of mistakes. So it is always easier to use standard form and apply these principles. But however, in mathematics, any method which you use, as long as it gets you to the correct answer, and as long as the method is correct in itself, yes, you can use the method which is easiest for you. Let's try again some other problems. Here we have 1.1 times 10 to the power 5 plus 2 times 10 to the power 4. So these powers are different. You would do yourself well to convert to power in 10. 1.1 times 10 to the power 5 plus 0.2 times 10 to the power 5. Why? Because this one can be written as 0.2 times 10 to the power 1 times 10 to the power 4. 1 plus 4 gives us this 5. So you can see here that we can add 1.1 plus 0.2, which will give us 1.3 times 10 to the power 5. Is it correct? Let's cross check. Yes, 1.3 times 10 to the power 5. Let's move on to the next one. 1.1 times 10 to the power 5 minus 2 times 10 to the power 4. When we are subtracting again, it is the same. We first, to make the work easier for us, it would be easiest to convert both the numbers to the power of 10, which is greatest. Like for in this example, it is 10 to the power 5. So it will be easier. 1.1 times 10 to the power 5 minus 0.2 times 10 to the power 5. We've already converted this in this step. We said this one can be rewritten as 0.2 times 10 to the power 1 times 10 to the power 4, which would mean that we are going to only add these powers, which is 0.2 times 10 to the power 1 plus 4, giving 0.2 times 10 to the power 5. So here it is easier. 1.1 minus 0.2, this gives us 0.9 times 10 to the power 5. Let's cross check if our answer is correct. And 0.9 times 10 to the power 5. Now what we need to do is to reconvert this number back to standard form, because it is less than 1. So this will be 9 times 10 to the power minus 1 times 10 to the power 5, which will be 9 times 10 to the power minus 1 plus 5, which would give us 9 times 10 to the power 4. So our answer will be 9 times 10 to the power 4, which is equal to this one. Let's try again another example. 5 times 10 to the power 7 plus 2 times 10 to the power 5. You can see there's a radical change here. Alright, but since it's addition, it is better to convert to this form. Okay, so that would be 5 times 10 to the power 7 plus 0.02 times 10 to the power 2. This is the same as this, times 10 to the power 5, which would be equal to 5 times 10 to the power 7 plus 0.02 times 10 to the power 7, which is now very easy. 5 plus 0.02 times 10 to the power 7. This is 5.02 times 10 to the power 7. Let's cross check with our answer here. Yes, However, here you can also convert this number to powers of 5 and then add and then reconvert back to the powers of 7. It depends on which way is easiest for you. Another problem, 6.2 times 10 to the power minus 2. In this next problem, we have 6.2 times 10 to the power minus 2 plus 3 times 10 to the power minus 3. Take note now that these powers are negative, so what we can do here is to just work around these numbers so that we can get either both in powers of minus 2 or powers of minus 3, and then we can do our working. I think it would be easier since this is the higher power or the bigger power, considering that on the number line minus 2 is bigger than minus 3. So we can rewrite 6.2 times 10 to the power minus 2 plus. Now we need to convert this number so that the power of 10 can be also minus 2. So for it to be minus 2, we can rewrite this number as 0.3 times 10 to the power 1 times 10 to the power minus 3. Okay, because 0.3 times gives us 3, and this one remains this one. So this will be 6.2 times 10 to the power minus 2 plus 0.3 times 10 to the power 1 minus 3 gives us minus 2. Now we have the same power, then we simply add these ones. 6.2 plus 0.3 times 10 to the power minus 2 giving us 6.5 10 to the power minus 2. Let's check if our answer tallies. Yes, 6.5 times 10 to the power minus 2. Let's look at the last problems. 9 times 10 to the power 10 plus 2 times 10 to the power 12. Here we can convert the numbers to powers of 12. It will be easier because our answer is going to be in power of 12 since we are adding. So here, since 9 times 10 to the power 10 is smaller, we can rewrite this to be the same as the number which we want here should be, we want to convert 9 to multiply it by 10 to the power 2 so that we can get, we can also by 10 to the power 10 to get 10 to the power 12. So 9 can be divided by 100, so to get 0.09. So we can say 0.09 times 10 to the power 2, because 9 can be rewritten as 0.09 times 10 to the power 2 times 10 to the power 10. Here you can see now we can add these powers to get 12 plus 2 times 10 to the power 12. And here what we are going to get is 0.09 times 10 to the power 12 plus 2 times 10 to the power 12, which will give us 2 plus 0.09, 2.09 times 10 to the power 12. Let's check if our answer is agreeing. Yes, 2.09 times 10 to the power 12. The last question is 3.2 times 10 to the power minus 4 minus 5 times 10 to the power minus 5. Since minus 4 is the bigger number here, so we need to convert this number to a power in minus 4. So it will be 3.2 times 10 to the power minus 4 minus, here you can see we can play around this number to become 0.5 times 10 to the power 1, right? And then times 10 to the power minus 5. You can already see that 1 minus 5 is going to give us minus 4. So it will be 3.2 times 10 to the power minus 4 minus 0.5 times 10 to the power minus 4. And then we just subtract these ones, 3.2 minus 0.5 times 10 to the power minus 4. So what we will get is 3.2 minus 0.5, this will give us 2. This will give us 3.2 minus 0.5 will give us 2.7 times 10 to the power minus 4. This, let's cross check with our answer. Yes, 2.7 times 10 to the power minus 4. Now you may be wondering, why the need for standard form? Why do we even need to do this? Why can't we just live our lives in peace and not be worried about these conversions and whatever? So you will notice that This often have to work with big numbers. For example, the number of people in a country, the number of people in the world, distances around the planet, etc. So, for example, the distance the Earth travels in one orbit is 558 million miles in one orbit. That is in its pathway around the Sun. We can express this number in a more concise form as follows to avoid ambiguity and, of writing large and complicated number with a lot of zeros in standard form. We can simply convert it to standard form. It will become 5.58 times 10 to the power 8. So this number is now written in what we call standard form, standard notation, or sign notation. That ordinary number is said to be in normal form. So scientists have to convert these numbers and have to make these numbers in a more concise and more easier way to relate to, so that large numbers can be easily compared and can be operated upon. Let's say adding and subtracting, calculate the distance that a rocket has to travel to reach Mars, to reach the moon, and what speed, etc., so that we can be able to know the world around us and be of relevance, and also be conscious of where we are in space. Let's meet in the next video. So that you can be able to know how to use and apply the standard form of length, you can watch this video where we have a full paper revision and all questions are there, and you see how the exam questions are like. Watch this video, click here on this link and enjoy.